adding and subtracting rational functions. First, let's remind ourselves about how fractions work when you learn these in the middle school. For number 1 there on the left, you can see that you already have a common denominator. We add those numerators, so it's going to be 10 over 4, which of course reduces to 5 over 2. Number 2, we don't have a common denominator, so we look for the least common multiple between 4 and 5, which is going to be 20. So we need to multiply the 5 by 4, which means I also need to multiply the 7 by 4 because you're really multiplying by 1. You're multiplying by 4 over 4, which doesn't change the value of the expression. So then the 4 needs to be multiplied by a 5, which means the 3 also needs to be multiplied by 5. So we say we're going to multiply by 5 over 5. So that's going to give us 15 over 20 plus 28 over 20, which is going to be 43 over 20. Now in the next one, we don't have a common denominator, so we need a common denominator. So again, it's going to be the least common multiple between 4 and 6. You might already know what it is, but let me remind you about least common multiples. When you're looking at your multiples of 4, that's going to be 4, 8, 12, 14, etc. And your multiples of 6, 12, 14, etc. And you're looking for the least common multiple, so the smallest number that's in both lists, that's 12. So once you figure out what the least common multiple is, you need to go back and say, well, in order to get from 6 to 12, I need to multiply by 2. I can't just multiply the bottom by 2, I also have to multiply the top by 2. Then for the 4, to get from 4 to 12, I need to multiply that one by 3, so I also have to multiply the top by 3. So then I end up with 9 over 12 plus 14 over 12. So that's going to be 23 over 12. In our last example, we have a denominator of 4 and a denominator of 8. The least common multiple between those is going to be 8. You probably figured that out already, but just to remind you, looking at your multiples of 4, so that's 4, 8, 12, 16, etc. Multiples of 8 are 8, 16, 24, etc. They have several numbers in common, but the least common multiple is going to be 8. The second denominator already has the 8, so we only need to multiply that first denominator by 2 to make it 8. So we're going to multiply the 3/4 by 2 over 2. So it's going to become 6 over 8 plus 7 over 8, which is, of course, 13 over 8. So one thing I want to point out about this slide is that in example number 1, we already had a common denominator, so we just needed to add it in the numerators. In example number 2, the common denominator was simply the product of the two original denominators. In example 3, the common denominator was some other number that 4 divided into evenly, that 6 also divided into evenly. And then example number 4, the common denominator happened to be one of the denominators, one of the original denominators. And so we're going to see the same thing, but with rational expressions. Let's take a look at number 5. First thing I notice is I have this denominator of x squared minus 4, which is the difference of squares. So I'm going to rewrite my problem. That's 1 over x plus 2 over x plus 2 times x minus 2. Now, when you're trying to figure out what your least common denominator is with these expressions, I always say write down the denominator from the first expression, which is x plus 2, and then everything from the second denominator you have not yet written. We already have an x plus 2, so what I'm missing is the x minus 2. So the least common denominator there is x plus 2 times x minus 2. So this second fraction, I don't need to do anything with it. It already has the least common denominator. But that first fraction only has the x plus 2. We need it to have an x minus 2. So I'm going to multiply the top and the bottom by x minus 2. So that becomes x minus 2 over x minus 2 times x plus 2 plus 2 over x plus 2 times x minus 2. You'll notice that in one fraction I wrote x minus 2 times x plus 2, and the other fraction I wrote x plus 2 times x minus 2. It doesn't matter because multiplication is commutative. Now that they have that common denominator, I'm going to go ahead and write it all over one denominator and add my numerators. Minus 2 plus 2 over the x minus 2 times x plus 2. In the numerator, that minus 2 plus 2, that just becomes 0. So my answer is just x over x minus 2 times x plus 2. So number 5 was an example where the common denominator ended up being exactly one of the original denominators. Let's take a look at number 6. In the first denominator, you have an x, which you can't factor that. And then in the second denominator, you have an x plus 6, and you can't factor that either. Remember, you have to think about these as factors and not just terms. A lot of students want to just say, oh, I'm going to add 6 to the top and the bottom. You actually can't do that. That's not legal. You would be adding 1 or a fancy version of 1, and that does change the value of the expression. You can't add 1 to an expression. You can only multiply by 1 because it doesn't change the value of the expression. When we're establishing what is our least common denominator, We just need to look at everything from the first denominator, which is x, and then everything from the second denominator you've not yet written, and these are going to be multiplied by each other. So it's going to be x times x plus 6. So that first fraction, we're going to have to multiply that by x plus 6 over x plus 6. And then the second fraction, we have to multiply by x over x. So let's write that down. So I'm going to have x plus 6 times 5x plus 2 times x over x times x plus 6 minus 2x squared over x times x plus 6. So now they are each written over a common denominator. And I also say here that another common mistake is for students to get to this step and then they say, oh, I can cancel those x plus 6's. Well, you can, but then you'd end up back where you started from. So you don't want to do that. So what I'm going to do next is I'm going to distribute all of this up here in the numerator, multiply that all out. And I'm going to also at the same time put everything over the one denominator since they have a common denominator. That's going to be 5x squared plus 2x plus 30x plus 12. And then I have that minus 2x squared all over x times x plus 6. And I combine my like terms and I'm going to have 3x squared plus 32x plus 12 all divided by x times x plus 6. Number 7. In the first fraction, my denominator is 3x minus 15. I notice right away I have a common factor of 3. And then in the second denominator, I have a 2x minus 10, which has a common factor of 2. So I'm going to rewrite this. I'm going to have x plus 10 over 3 times x minus 5 minus 3x plus 15 over 2 times x minus 5. Some common mistakes here is students might think that you can somehow reduce or cancel these 3x's here. You can't do that because these are not common factors. 3x is just a term for that whole factor. Same thing here. 3x is just a term for that whole factor. You could, of course, factor out a 3 from the numerator here, but that doesn't help you at all, so I wouldn't even bother because you can't cancel. There's a 3x plus 5, and down here that's going to be an x minus 5, so nothing cancels. Okay, moving along. Looking at my common denominator, my least common denominator is going to be everything from the first fraction, so 3 and x minus 5, and then everything from the second fraction or second denominator not yet written. I don't have a 2, so I need that 2 times 2, but I already have the x minus 5. I don't need to write it twice. So my least common denominator is 6 times x minus 5. Now let me say this. If you had written that your least common denominator was 3 times x minus 5 times 2 times x minus 5, you would still get the correct answer, but that's not the least common denominator. That would just be a common denominator. And you'd end up having to do a lot more simplifying at the end. So now that I know that my least common denominator is 6 times x minus 5, I need to figure out, well, this fraction is 3 times x minus 5, and I need to be 6 times x minus 5. So I have to multiply the top and the bottom by 2. And then this fraction, it has a 2 times x minus 5. I want it to be 6 times x minus 5. So I multiply the top and the bottom by 3. So now I have 2x plus 20 over 6 times x minus 5 minus 9x plus 45 over 6 times x minus 5. You're welcome to distribute the 6 through to the x minus 5 and call it 6x minus 30, but it's not required. Now in the next step, I'm going to put everything over my one denominator. I also need to distribute that negative. This is very common mistakes here for students to forget to distribute when they're subtracting. So I'm going to have 2x plus 20 minus 9x minus 45, again, distributing the negative, over 6 times x minus 5. Collecting my like terms, I have negative 7x minus 25 over 6 times x minus 5, or if you'd like, you can call it 6x minus 30. One of the reasons why I like to keep my denominator in the factored form is because if this 7x minus 25 had been factorable, like if it had been 7x minus 28, I would maybe take out the 7 to see if I then have a common factor, but I don't, so I'm not going to. Number 8, looking at my first fraction, I have a 2x minus 8. I notice that has a common factor of 2. And then in my second fraction in my denominator, that's a trinomial and I could probably factor it. So in the first one, I'm going to go ahead and pull out that 2 and I have x minus 4. And then in the second fraction, that does factor as 2x plus 1 times x minus 4. Your techniques for getting from there to there would either be splitting the b or a guess and check. I'm not going to show you that in this video because that was from a previous lesson. Now, analyzing what is my least common denominator is going to be everything from the first denominator, so 2 times x minus 4, and everything from the second denominator I have not yet written. So I have a 2x plus 1, but I already have an x minus 4, So I need to include the 2x plus 1. In my first fraction, the denominator doesn't have the 2x plus 1. So I had to multiply the top and the bottom by, you guessed it, 2x plus 1 over 2x plus 1. And in the second fraction, I have 2x plus 1 and x minus 4. What I don't have is the 2. So I multiply the top and the bottom by 2. So on the left, we're going to have 6x plus 3 over 2 times 2x plus 1 times x minus 4. Then we have a minus sign, and that's going to become 2x plus 2 over 2 times 2x plus 1 times x minus 4. Now I'm going to put everything over the one denominator, remembering to distribute my negative. 6x plus 3 minus 2x minus 2 over 2 times 2x plus 1 times x minus 4. Collecting my like terms now, 4x plus 1 over 2 times 2x plus 1 times x minus 4. Just taking a look, I don't have any common factors in the numerator, so I can't take out any greatest common factors, so nothing else is going to reduce. Number 9. Here I have a trinomial in that denominator and yet another trinomial. So I'm going to factor both of those. So I'm going to have 2 over, this will factor fairly easily, just two numbers I multiply to be 6 and add to be negative 7. So that's going to be a negative 1 and a negative 6. And two numbers that multiply to be negative 6 and add to be negative 5, negative 6 and positive 1. And of course there is a 3 on the top there. Going over here to the side, I'm going to write down my least common denominator. Everything from the first denominator, minus 1, x minus 6. And everything from the second denominator I have not yet written. I already have an x minus 6. What I don't have is an x plus 1. So that means that in this first fraction, this one doesn't have the x plus 1. So I'm going to multiply the top and the bottom by x plus 1. And the second fraction doesn't have the x minus 1. So I have to multiply this one by x minus 1 over x minus 1. So distributing the 2x plus 2 over plus 1 times x minus 1 times x minus 6. And then over here, 3x minus 3 over x minus 6 times x plus 1 times x minus 1. You'll notice that order is different here, but it doesn't matter. Now I'll put everything over that common denominator and combine like terms. So first put everything over 1, 2x plus 2 plus 3x minus 3, all divided by, collect my like terms, 5x minus 1, all divided by x plus 1 times x minus 1 times x minus 6. Once you get more comfortable with this, you'll be able to skip some steps. For example, when I went from here to here, here to here, I could have gone ahead and written all of that over that single denominator and sort of combined this step, or essentially I would have gone from this step directly to this step, and that's totally fine. A lot of students that want to ask, do you have to leave it in this factored form? No, you don't. As I already said, I'd like to do it in case I have a common factor with the numerator. I hope you enjoyed that.